Oh yeah, this is going to be huge. We're going to go over the concept of the derivative in this video. We're going to start out with a classic understanding of how to find the slope of the tangent line at any point, c comma f of c. What does that mean? Well, let's check that out right now. So let's say you've got some curve f of x, and you've got a point right here, and that point we'll call c f of c. Not so bad. So that means we took an x value, called it c, plugged it into the function to find what the y value is, and we got f of c out. That's this point right here. Our goal is to find the slope of the tangent line, which means what is the slope of the line that barely skims this curve and only touches f of x at this one point. This right here is known as a secant line. It's a curve, I should say a line, that touches the curve at 2 points, goes through it. Our goal is to find the slope of this. How do we do that? Well, glad you asked. Let's check this out. What we do is we look at this like rise over run. And so just like normal slope goes, we look at this and I make a rise and a run, and that's what we're going to find of that secant line. So this amount right here is either known as h or delta x. I'm going to write it as delta x. That means the change in the amount that we've gone in the x direction. And this amount right here, well, we're going to find that out in a second. So what is this point going to be up here now? Well, if we go over delta x and we start at an x value of c, we've gone c plus some amount delta x. So the x value of this point is now c plus delta x. From there, we plug that x value into the function to figure out what the y value is there. So that's f of c plus delta x. Not so bad. Very nice indeed. So how do we find the slope? Well, let's find the slope of this secant line right here, and we're going to use it to find the slope of that tangent line. Well, the slope of any line is y2 minus y1. Let's start there. y2 minus y1 all over x2 minus x1. Oh, what am I blabbering on about with all that algebra 1? Well, here's y2. And here's y1. Let's plug it into our formula. So the slope of that line is going to be f of c plus delta x minus y1, f of c. So that right there got you your rise. It got you this amount. All over x2, that's this right here, minus x1, this minus that. So that's going to be c plus delta x minus c. Ah, very nice. Now, we simplify this down. The numerator is just going to stay the same, so I do a lot of copying. So I'm just copying down that upper part here. And for some of you might be looking at this like, what does this even mean? Bear with me here, it's going to be pretty wicked. C plus delta x minus c's, those two constant, those x values, the c values cancel, and you're left with delta x. That right there represents the slope of that line right there. But we don't want the slope of that line. We want the slope of the tangent line. How do we get that to happen? Check this out. Essentially what we're going to do is we're going to bring this point along this curve closer and closer to this point here. So if I put a point there and then I draw, let's see, let me draw another secant line. So I'll do that and I'll do it real thin. So we got a new secant line like that. Well, okay, then let me see. Well, if I bring the secant line a little bit closer like that, what happens? Oh, we get another secant line. Beautiful, it gets closer, and you see that this line's slope is getting closer to that slope right there. Let's do one more point. We get even closer. Delta x is getting smaller. Much smaller, right? That's what's happening. We're shrinking down delta x. And eventually, we want delta x, this width, as you see, to go to 0. If delta x gets really small, we will have that the slope of this secant line will eventually become the slope of that orange tangent line. Essentially, we're doing, oh yeah, the limit as delta x approaches 0 of that right there. Now, if you've learned it in class, that might be the limit as not delta x, but some people write delta x as h. So just so that you see this too, that's f of c plus h minus f of c all over h. Some people see it that way, and some people have x values in there for the c's. No matter what, it's important to see that the limit brings these secant lines closer and closer to that point where it becomes a tangent line. That's a beautiful, beautiful thing. Oh, and it comes from rise over run. Oh man, I love it. Now, that's it for the formal definition of the derivative. We're actually going to use this in a little bit. This video is about explaining where this function comes from. Now, what I'm going to do for the second part of this video is I'm going to show you what's known as the alternative, sometimes called the alternate definition of the derivative. If you don't care about it or you don't need to learn it, just turn off the video now. But if you need to know it, and if you're in AB or BC advanced calculus, then you pretty much need to check it out. So it's going to be very similar to what we just did, the alternative definition of the derivative at a point. We're going to start out again with c, f of c, and that's on the curve f of x. And it's the same idea of bringing secant lines closer and closer to the tangent line. So that's c, not f of x. Let's go backwards there, c comma f of c. That's just any old point on the curve. And this point right here, that's just going to be the point x comma f of x. We don't do any kind of delta x or any kind of h value. And now we find the slope of that secant line, which is f of x, that y value minus this one, minus f of c. That gives you y2 minus y1, all over x2 minus x1, or the change in x. Now that gives us the slope of the secant line. Again, we want to bring this point here closer and closer and closer and closer until the secant line gets really close to and basically becomes the tangent line slope. How do we do that? We need to take the limit as x approaches c. So as this x value approaches c, we will have the slope of that tangent line. And there you have it, peeps. That is the alternative definition of the derivative at a point. That's it. So this video again was to summarize and hopefully give you a good idea of what it means to have a derivative and why that formula does not just come from thin air. It comes from slope. See you soon.